hopefully more people join. So welcome everyone to this webinar. So we're going to be speaking today about secure architecture principles for full stack applications, and we're specifically talking about web applications. And we'll have a kind of a real design session, if you will, whiteboarding session. And and this is our team here, Software Secured. So I'll just share a little bit about us first. So essentially, Software Secured is based in Ottawa, Canada. We do mainly penetration testing from a security perspective, of course. And we do one-time testing, but we also do penetration testing as a service. We do a lot of other like security-related offerings, so security code review for multiple languages, threat modeling, secure code training. So for any dev teams or any even non-technical teams that need training in security, we can definitely provide that as well. So before we start, just wanted to do a kind of quick round of introduction. So essentially, we'll just go through and introduce ourselves first and just get started. So myself, my name is Imad. I am the dev manager here at Software Secured. I'm joined with Sharon.
Hey everyone, I'm Sharon and I'm the tech lead here at Software Secured.
Awesome. And just to get a sense, I know this is a webinar format, so just to get a sense of everyone's background and to get to know you a bit more, so we'll just be sending out a quick poll here just to get an understanding of where everyone is at and what are you looking for from this webinar so that we can best kind of tailor the content as well. We'll take a few minutes for everyone to fill that out. Okay, I don't see. Hopefully everyone is seeing the polls. Just send us in chat if you. Okay. So is it showing up okay now? Okay, second question worked. Sure, we can put in the chat as well. Yeah, that would be helpful too. If anyone's having any issues, yeah, feel free to post it in the chat and we can read it from there too.
Let's just give 5 more seconds on this poll.
Yeah, sure. Cool. So as people are posting in the chat, if you have any, like if you weren't able to kind of fill the survey, but I'll read out quickly the results from here, is that we have about 30% like other industries that are other than the ones that were listed, but the other other 60% were kind of between. We have like the highest one is finance and insurance, followed by manufacturing, supply chain, and security. So, and then followed by healthcare and retail and marketing. Okay, it's good to know. Very good. Okay, newer student network security. Awesome. Welcome, Michael. We posted another kind of survey quickly there, and just to understand your role as well. And thanks, Michael, for sharing that. Hopefully this helps you with your studies. We'll give a few more seconds there. All right, we have a Scrum Master. Awesome. It's great to have you here.
5 more seconds.
All right, thanks, Alex. Okay, so we have over 56% developers. That's great. 19% team leads. That's good. Followed by 13% of other, and then we have a few marketing and a few consultant analysts. Great. This is awesome. Welcome, everyone. We have one last one. Yeah, I'm not sure what the phone experience is like for the polls. It should be integrated into Zoom, but I'm not sure what the experience is. So I apologize about that. We can revisit that for upcoming webinars. But essentially, the last question is essentially if you have been part of a pen test, yes or no, or yes multiple times, or you don't know what a pen test is. So that's the last question there.
And about 5 more seconds on that one as well.
Amazing. Okay, so half of the audience have not been part of a pen test, and then between 17 to 13, they have been there or have done a pen test once or multiple times, and then we're at the 17% that would like to know what a pen test is. Okay, great, amazing. Okay, the more button. Thanks, Michael, for sharing that. Okay, awesome. I think we're good to go. So thank you everyone for participating. So, all right, without further ado, so we're going to talk about secure application architecture. So what we're going to do, the format for today, we're going to have actually an app that is kind of a made-up app or a made-up set of requirements. We're going to go through, Sharon and I will design this application in a whiteboarding session, or whiteboard format, and go through a lot of practices that we believe can give you a pretty strong foundation in a secure application. And just a caveat or a disclaimer here that yes, we do cover a lot of ground today. We don't cover 100% of the ground because practically it's not possible. There's a lot of things that can go into security that we can talk about, from everything from like devices to or like infrastructure to kind of code. So we are covering a lot of ground, but not 100%. But we are covering the ground that has allowed us from experience to build applications that withstand or come up with pretty good results when it comes to penetration testing. So that's from experience building applications and going through multiple pen tests ourselves. And kind of, so it's a hybrid between best practices and our own experience. So what a pen test is, just so that for the people who wanted to know, pen test stands for penetration testing or penetration test. And what this is essentially a service where ethical hackers, or essentially hackers, are hired to essentially conduct testing on what an application. It could be mobile app, could be even a physical building, could be a web application. And they try to penetrate this application and present the results to the company that asks for that service, so that the company can kind of fix any vulnerabilities that were found. So that's penetration testing or pen testing. And yeah, so we can definitely jump right in. So yeah, without further ado, I think Sharon, you've met with the client and you've gathered the requirements. So let's jump right in.
All right, so looks like we're building Noteware Secured. They've described it as just a private notepad per company, maybe something like a really basic form of Notion or a really basic form of a Confluence page. They'll want to be able to log in with a company email provider in order to access the app. So already I'm thinking, okay, there's some authentication flows there. There's some privacy of information. The notes may contain secret information. It's giving me some multi-tenancy vibes. Okay, and along with that, there's some access or role requirements. Some users can edit, some can only view. So we'll have to think about protecting what might be our endpoints here. And lastly, they've mentioned they want to be able to integrate with external apps. And they've talked about maybe Slack, maybe Jira. So we'll need to expose an API of some sort to allow them to do that.
Yeah, that's interesting.
All right, so just to further illustrate that, we're looking at what seems to be a multi-tenant cloud-based SaaS application. So if we have company A in red on the left here and company B in yellow on the right, we'll want that clear separation of data. And what we don't want happening is company B seeing company A's private notepad or vice versa. So as we design this, we'll have to keep in mind that that is one major priority.
Okay, amazing. So yeah, so it's a web application for note taking or document kind of storage. You can think of, yeah, like you mentioned, Confluence or Notion. Okay, cool. So we have a few topics that we're going to cover. We do need a web app, obviously. We do need an API as well that is external facing, which means other kind of third-party developers can use to write integrations. We're definitely going to need to talk about authentication authorization, given that it's a multi-tenant SaaS application. There's no escape of database and storage topic. And finally, we would want to, no matter how secure we design our application and build it, we will need to talk about security testing and more specifically effective security testing. And lastly, even during deployments or even after deployments, we're going to talk about that as well in our design. So we'll start with the first layer, which is the web apps. So essentially, we would usually have, we're assuming we'll have a single page application here. We have a front end, we have a back end, which is probably going to act as our API as well. So one thing that, you know, right off the bat, this one is easy. We can check off the list is using HTTPS for all communication. And specifically, it's good to pay attention to that is that you need to use TLS version 1.3 or later. Right now, it's version 1.3 is the latest version. Obviously, if newer versions come in, we should use them as well. Yeah, I don't know, Sharon, what else do you think there needs to be here?
Right. Well, I think it's a great first step to ensure we're using a secure connection, but we should also make sure that we're not just accepting requests from anywhere and that we're specifically accepting requests from our front end. So something that we can do there is set up a reverse proxy so that we can access the backend via the same origin. And to do that, we can set same site strict to ensure that it is coming from the same site. And as we said, we want to be using that secure connection.
Right. Yeah, and I guess that's mainly we could have the endpoints that are related to the front end app, like as their own set of endpoints that are accessed through that same site strict. Okay. It reminds me of, you know, this setup is great. I just remembered a few things where we got burned by in the past, where we have a hacker here that was able to embed our site in an iframe and then have a bunch of ads around it so that, you know, people can click on and they were able to compromise some personal information there. So I just can't remember how we fixed it. Do you recall?
Right. So we were pretty concerned about that and it seemed like a huge problem, and it was, but luckily we were able to figure out that an X-frame header was missing. And we ended up going with deny. So we're preventing anyone from including our site in an iframe.
Right. So the sort of response header, as long as this has this X-frame header value deny with the value of deny, then we should, you know, no one should be able to embed that, I guess. Okay. Yeah. Kind of in a similar kind of thread there. Another attack is basically from a cross-site perspective. So if there is another tab that a user, like, or a hacker basically could somehow have the user open while they have a session in our site open, you know, that other tab could send malicious kind of payloads to our active session. I know we have same origin, so that kind of should help a little bit. But if we don't, we still should have some sort of protection, you know, as an extra layer there.
Totally. Yeah. It's always important to have multiple layers of security. You never know if we might miss something or just forget. And so what we'd be looking at here is cross-site request forgery, or CSRF protection. So being able to send a request through another website to our website would be that cross-site action. But what we can do there is we can guard all post requests that are going to our site and ensure that any requests going to our site have the proper authorization to do so.
Mm-hmm. Yeah, and I guess that, like, there are multiple techniques. I've read a little bit about it. The double token or double cookie, or there's a lot of techniques with CSRF, so definitely encourage, you know, more reading there. But I guess, I mean, this is good enough. I guess for convenience, what do you think, Sharon? I mean, we're going to be doing a lot of QA, so might as well just have this, you know, the testing site or the staging site, like, publicly available. Just so that we can kind of have a bit more convenience, you know, like, I just don't want to log into my VPN every single time.
Right. I mean, I get where you're coming from. It is convenient, but it's, you know, having your staging site, even if we don't necessarily have private data there, it's not the best idea to have it accessible. Other people could be hitting our website and take staging down while we're testing something important. So I think we'll still need that VPN in place. Maybe we'll have a firewall block. We might have an allow list of IP addresses that can access our staging site, but we'll need to protect our non-public resources to make sure that only we are accessing our staging website.
Sure, sure, okay. I mean, yeah, it might also help with, like, if we have any debug kind of logging turned on, they might kind of, the debug messages might give the hacker more information about our infrastructure. Okay, fair enough. Okay, so now we've talked a little bit about that. Let's design our session management. I think you'll agree with me, but we can't live without cookies, right? Whether it's like they're physical cookies or actual web cookies. But you know, so something like that we definitely need. And but I did read online that cookies can be hijacked. So yeah, I don't know how to solve that one.
Right. So yeah, it's important. We'll need to protect what we're doing with cookies, and we're not totally lost here. We have a few options. There's a few different attributes that we can set when we're setting a cookie. So first of all, one thing we can pay attention to are HTTP only cookies. And what that means is these cookies would only be accessible via the HTTP protocol. And we'll want to do this because I think we're planning on managing cookies with our server and not let them just be manageable in the browser. That's because it's possible that JavaScript can be used to tamper or use the cookies, and that's not what we're looking for here. So let's use HTTP only. The other one, this one might be a bit obvious, but setting the cookie expiry, or there's also max age, which can be used to set the expiry. And this is important because we don't want the cookies to just hang around forever. I don't know, maybe we would be logged into the browser somewhere and you leave your laptop there and your cookie doesn't expire. Someone could just, you know, sit down at your laptop and access the app and look at all the private notes. So we want to set that expiry so that even in that situation, hopefully the cookie expires and terminates the login. And lastly, marking them as secure. So when we are accessing the cookies via the HTTP protocol, we'll want to make sure we're transferring that information with secure connection. So we'll require HTTPS by specifying the secure attribute. And then that helps us make sure that headers sent with these requests aren't just exposed as plain text.
Okay. Well, that's definitely makes me a little bit less anxious. Okay, I guess one other thing that we need as a feature is if a user kind of tries to navigate to a page in our website and they need to log in first, we usually redirect them to the login screen. And then after login, I think it would be a good user experience if we return them back to, or redirect them to the page that they were intending to go.
Right.
But what I've seen with that is that sometimes this could lead to phishing attacks. So what a phishing attack is basically, someone could use our URL redirect mechanism. Let's say it's a query string parameter. They could put in another website that is kind of malicious, and they could redirect the user. And from a user perspective, they think that they're going to our domain, but they land on a different website. And then they could provide sensitive information there. So yeah, I mean, that one is also a concern.
Right, right. Well, I think what we can do there is we can try to avoid query strings whenever we can. But more importantly, if we're using any sort of redirect, or if we're passing them to a new URL at any point, what we can do is set up an allow list for the URLs, probably basically just our domain. And so if there's any redirects that the URL gets tampered with, and even if it goes to cutepuppies.com, we still don't want that. So we'll ensure that it's the software secured domain.
Awesome. I'm just noticing as well, like I'm seeing a few messages on the chat and questions. I think we're definitely happy to answer them. And I could maybe answer the few of them because these are quick, and then we can continue. But basically, TLS is the essentially the version of the certification in protocol in HTTPS. I can look up the acronym exactly, but that's kind of what it is. And usually that's provided by the signing authority. So whoever signs the certificate, so it could be your hosting provider, could be yourself if you're generating the certs, but you'll just need to use that version for it. So HTTP 2, yes, definitely like recommended for kind of just using the latest for that. Also, the reverse proxy is not to get around CORS directly. The reverse proxy is to facilitate getting around CORS. So yes, the answer would be yes there. Thanks, everyone. We do have a Q&A section at the end as well, so we can definitely answer more questions there. Okay, Sharon, so we covered a lot of bases in the web app side. I think we need to jump into authentication.
All right, let's do it. Okay, so once again, we have our front end where our users are going to be logging in to their company note page. We'll have our backend API, and we're going to have some sort of API integration with some third-party apps. Mm-hmm. So in between the front end and the back end, that means we'll need, like I said, for login, let's just do username and password. We'll store the credentials in the database and return a session token. So we're super secure, right? Like we have a session token, we're going to expire their login, we're all good there. And then on the API integration side of things, we just need the API key and secret, throw that in the database, we're all set. Easy.
Yeah, so I mean, this is it's a good start, but I think we are taking on a lot of responsibility by storing the username and password in our database. So storing them is a big responsibility that we need to protect that information. I know some applications require that or not have an option. Luckily, this application has a requirement for identity providers to use like an email provider. I mean, we should also consider that if we, even if we don't have the requirement, is to use identity providers and use something like OAuth 2.0 to log in. And this way, we offload the actual credential storage and the authentication to another service. And the OAuth 2.0 process usually requires us to register with that service. So there's like a trust that's built. And then all we need to store is probably just the email address, and that's about it. That kind of alleviates a lot of the pressure there. So I think that's a good practice.
Okay. I do like that a lot better. And like you said, that's already a requirement. So that works great. It's making me wonder though, what about the API key and secret? Do we have to worry about anything there?
Yes, you're absolutely correct. So, I mean, the concern there is that integrations are going to come from potentially anywhere. And, even if we provide a API secret, key or secret, if they pass that with every single request, there's a high risk of damage, or a higher damage that could happen if this credential is being passed with every single API request. This means if this request got compromised, or this API key or secret got compromised, then they've compromised the account or compromised the credentials. So what's recommended there is actually to exchange the key and secret as if it's a login request with a session token. And then it follows the same thing as the web login, where we actually have a session token that we can expire. And this way, even if this session token got, there are less chances for the key and secret to be compromised, and then more chances for the session token. But even if it got compromised, it will expire. So they won't, the damage would be, at least it would be minimal.
Okay. So I like this pattern that we keep using with the session token. It seems to be serving us well. But what about our backend API here? Is it protected? We're only planning on connecting it with the front end and API integrations, but it kind of seems like we could just get traffic from anywhere.
Oh, that's a good point, actually. Yeah, it's different because we said like it's third party, so it could be from anywhere. And the same origin that we talked about in the previous slide, that's probably, fits the front end web. Okay, so for that, we should probably have an API registration process. So if someone needs access to the API, they have to provide us with a list of IP addresses that we can allow. So, and this way we can validate if the traffic is coming from a different IP that we do not recognize, then we do not allow that request. And this way, we only allow requests from the IPs that we know and we explicitly allow, as opposed to, just anyone.
Okay, awesome. Okay, so let me gather my thoughts here. So for the API, what we want to do is not send credentials on every request. Like we said, we don't even really want to store them anyways, if we can avoid it. So we'll do that. We'll authenticate them, exchange it for a session token.
That's
and
right.
One other thing I guess to remember is just validate and sanitize any inputs we're getting from anywhere. Never know what's going to be there. So
absolutely, that's correct. Yeah. And then to your point about storing credentials, it's probably better to use OAuth or use an identity provider. Also, we have to understand, like, the fact that we have a session token does not, necessarily mean it's secure. The session token itself has to be encrypted, and we have to use a strong encryption algorithm, not just any hashing algorithm. So an example, one of the strong ones today is AES 256 CBC. So this is probably what we would recommend. As also, like you mentioned, Sharon, like all tokens has to have an expiry. Every single piece of credential kind of or session kind of data has to have an expiry that forces it to be invalid. And then for the web tokens, we mentioned this already, but it should still have HTTP only if if we set it in cookies, and this way it's handled only by the front end.
All right. Okay. Well, I think that makes sense to me. Maybe we can talk about authorization and access.
Yeah, let's do that. So access control. So essentially, we talked about the requirements here. They do need some users to be able to do some things and other users to be able to do other things. So I think one kind of pretty good pattern is to separate the URLs between user roles and admin roles. Let's say we have a user role and an admin role. We can separate it that way so that even if a user wants to do something as an admin, they don't know the URL. And so they won't even try to access it. What do you think, Sharon? I think this is a smart idea.
Well, what if they can just guess the URL, or what if their coworker just sends them the link by accident? They shouldn't still be able to access that, right?
Yeah, that's actually true. Yeah, but how would we overcome that then?
Right. Well, let me think. I think we'll need some access control logic, right? So we can start off with a pattern like aspect-oriented programming, and that will allow us to call functions before we execute business logic. And then we can ensure that the user is authorized before we carry out the action. So we can use that for our cross-site request forgery guard, and we can use that to double check that they're actually authorized.
Yeah, that makes sense. I know aspect-oriented programming is like a good pattern, like in general, even for quality of the code. But I can definitely see how it's beneficial in security, where the logic is injected automatically into every request. I do also know that single responsibility principle, which means a certain function or method is contained in one place. What this helps with is that if we're creating a block of code that is responsible for authorizing, let's say, admins, if we have that in one place, then what this means is that it's either going to work everywhere or work nowhere. And the reason this is a good thing is that it's easier to catch if it's not working, as opposed to copying and pasting the same code multiple places. This probably is a better pattern and just gives us less chance for us developers to forget.
Awesome. Okay. I think we have some good layers there, but with security, we like more and more layers. So in the case that someone doesn't get access because they're not authorized, we don't necessarily want to let them know directly, especially if a hacker might be trying to penetrate our system. So we can do a little bit of error code obfuscation, and this is okay because we're using REST here. So the purpose of this is we might send the error code 403 forbidden, and that would mean that our server understood the request, but specifically we refused to authorize it. But doing that, we might be disclosing some unnecessary information because a malicious actor might think, okay, I know that I'm not authorized to access this resource, but I know it's a valid resource. So maybe I can attack this in some other way. So what we can do is, instead of doing a 403 forbidden, we could maybe do a 404 not found. And that would mean that the server understands the request, but we're just going to say we couldn't find what you were looking for. And that way we can confuse the hackers a little bit, but we're still able to allow the user to understand something went wrong and it wasn't your fault, but we weren't able to find it. And for our purposes as developers, we can have logging that makes a little bit more sense. If we did something like use a 400 bad request, that wouldn't really balance the confusing the hackers and the user experience, because the users would think, oh, I just clicked on this thing, and why is it telling me that I corrupted the request? That doesn't make any sense. So I think if we did 404 not found, that would give us a good balance there.
Got it. I see. Yeah, that actually is a pretty good point. Okay, sounds like we've covered a few bases there. How about we talk about storage? Because I think this one is probably the easiest, because the database is just not connected to the network, or at least not the web directly. How about that? Let's talk about it.
Let's talk about it. Not sure about how easy, or, we'll see. We'll see.
Oh, it's gonna be fine.
Well,
yeah, it's just gonna be a it's just gonna be a database, right? Where we have all the documents. And we're going to have like a few fields there. So we'll have the ID, which is kind of the typical auto-generated kind of primary key. Let's say we have a title of the document HTML, the company ID, because we're kind of going to have a multiple kind of like a multi-tenant SaaS application. So we'll need to know which document belongs to which company. We'll also need, we'll probably need some sort of URL column here to maybe there's a webhook kind of configuration there that they put in, or some sort of integration they have. And I'd really like when we kind of answer support tickets quickly and find out the client's problem quickly. So when they submit a problem, we can connect to the database quickly and get to the bottom of it. So we should probably, just enable remote access somehow to the database so that we can quickly support them. Yeah, I think we should move to the next topic, right?
Oh, Ahmad, we've talked about this already. We don't want to be exposing these things publicly. I know that it's very convenient, but we don't want to, we don't want public access to our database. We don't know what they're going to do with the data. It could be really bad. So unfortunately, I'm going to have to put my foot down on that one.
Okay, sure. But I think we're ready to move otherwise, right?
Oh, well, let's take a look at the IDs over here. So I see that they're just incrementing by one. So
Yeah.
that's something that a hacker could easily enumerate. You can identify the pattern as just ID plus one. That might be one of the first things they try. That's not good because if they're making database requests somehow, all they have to do is increment the ID, which looks to be the primary key in the situation, and they'll be able to just get all of our user data. And that's really bad news. So what we'll want to do is make that ID less guessable and basically look random so that they can't deduce any sort of information. And how we can do that is by using a UUID, or a universal unique identifier. And that basically looks like a bunch of letters and numbers, and you won't be able to add one and get the next one, essentially. So if we use something like an object relational manager, or ORM, and we define a base model, we can set our primary key to be a UUID. And then anything we create on top of that, any new tables, any new objects, will have that UUID primary key by default. And then we can throw in anything else on top of that, username, first name, etc.
Okay. Okay. All right. Yeah. Well, that's solid then, I guess.
Oh, okay. Well, let's go to the next column here, or the third column, the HTML column here. I know you were thinking we just have a bunch of string content, it's all good, but you never really know what's going to be in the HTML. We could find ourselves with some scripts in there that might lead to cross-site scripting or XSS, and we don't want that. So let's double check that all of the inputs that we're getting are sanitized. We try to detect if there's any issues with it. We can escape characters appropriately, and we can make sure that the data type is correct for our database models. So that's another check we definitely want to have in there. We don't want there to just be arbitrary code that can be executed.
Okay, now I'm thinking, what else am I missing here?
One more thing, that URL. So URLs are kind of scary, like we mentioned earlier. Remember how we're concerned about phishing attacks? You never know where a URL might lead you. So again, let's make sure that we have our allow list set up for this, so that we're only expecting specific URL domains, and that none of these URLs are, again, even if it's for cutepuppies.com, that's not what we're trying to send our users. So let's make sure again that they're software secured domains.
Right. Okay. I mean, that's pretty good, but I mean, at this point, we've went through all the columns. I imagine there's like nothing else that, we should consider, right?
Well, okay, well, we haven't gone through all the columns. There's the company ID column, right? And you even said multi-tenancy, which is already, like we discussed earlier, a big factor for this app. So we'll want to make sure that we are separating the company data as much as possible between companies. So instead of having a single database and having every single company's information in one database, might be a better idea to separate the databases so that there's one database per company. And that way, each client or each company, if there's a data breach, if they get into one database, they're not getting into every single company.
Okay. This is some advanced stuff here. I mean, it's going to require a little bit of extra coding there, because we need to switch connections, depending on the logged in user. But you know what? Here's another one to top it off, just so you know that I actually know about database security. So we can actually add encryption at rest as well. So this is kind of basic, but we should probably encrypt our database at rest. So what at rest means, it means that where it's stored, the actual kind of data stored in the disk. So let's say hypothetically, if someone got access to that database server, they wouldn't be able to decipher the contents of the database.
That's a good one. That's a good one.
How about that?
Well, I'm going to one-up you on there and say that why don't we have a separate encryption key per company so that each database is encrypted with a different key. And that way, even if a hacker was able to find the encryption key for one database, they couldn't just turn around and use that encryption key for the other database.
Okay, all right. I'm starting to get a little mind blowing here. Okay, so what about encryption? A separate encryption key per user.
Oh, okay. You're catching on. Nice.
Yeah, this way, even if they get access to a user's account, they will only be limited to the content this user has created or has access to, as opposed to the whole company.
All right. Well,
see, I'm catching on. I'm not too bad here.
You're doing good. I think you're doing good. We're ready to move on to security testing.
Okay, sounds good.
Okay, so we've spent all this time figuring out how to architect our app, and even though we're making some good secure choices here, there's always some room for error. You might forget a header, you might just configure something slightly incorrectly, and so we'll want to be running some tools to catch those cases as well. Sometimes they can be really bad too, just forgetting something small. So yeah. While we're in our testing or staging environments, let's make sure that we're running some static analysis tooling or SAST. So we'll be able to access SAST tools via IDE extensions. There's a few extensions that I've personally used in VS Code. I really like setting up jobs on GitHub. So pre-commit or pre-push, we can run some static analysis tools. We can also throw it into our CI build process. And part of that could be actually running those in our build processes on pull requests or merge requests. So in addition to the code review, we can make sure that we're scanning the new code additions as well.
Okay. All right. That's very important for sure. So, I mean, along the same lines, just in addition to static, there's also dynamic application security testing. And what this is there are tools out there that are automated that what they do is they run it against a running, or they execute against the running application. So if we have a running instance of the application, be it localhost or even like on a staging site or testing site, we can run these tools against them. Example, StackHawk is one of them. There are many of them, Zap or others as well. Mm-hmm. So what we do need is we do need to run the app or deploy it somewhere in a pre-production environment, and we could put it in a CI/CD job as well. And what Dast would do is it would kind of try to submit malicious payloads or just insecure payloads in general, and try to define if, based on response codes and response sizes, whether the application could be vulnerable to that or not. So that could be an interesting also test as well, because the SAST scanners would cover kind of the semantics or data flow vulnerabilities, but Dast actually covers things that are more on the runtime side of things.
Nice. Okay. And speaking of runtime, we'll have our running app in production at some point. And so we'll want to set up some observability and monitoring tools that will help us look into our server and container logs and traces. We can also use analytics that can give us some insight into what's happening, what are our users doing, are there certain paths that we need to pay attention to more. We can get a sense of our app status by looking at if there's errors occurring, are there failing requests? And then there's some other tools we can look into. There's RASP, or Runtime Application Self-Protection. And those would be tools that monitor the app's activity while it's running. So it's able to detect things like things it thinks are malicious activity. And then from there, it can block that activity. It can terminate a user session if they think a specific user is doing something weird, or they can even shut down the application if that's needed. And then another similar type of tool is SIEM, or Security Information and Event Management. It's kind of similar. It does do some monitoring of the app events or app data, but it pulls this from any sources that are emitting any sort of event data. So our logs, if we have anything else, and it aggregates all that information and identifies possible attacks or breaches. And then it can send us an alert when it thinks it matches a pattern. We can set security gates. And this can also be helpful if we need to do some sort of audit down the line, but hopefully we don't have to. Yeah,
Very
so
cool.
we can do that for production. And actually, one more thing, we can even add something in on the repository scanning level. This could be part of SAST as well, but we could also just run code repository scanning against our repo, just to make sure we didn't accidentally throw in some leaked passwords or secrets or anything like that.
Yeah, that's a good idea. I know some of the, like, for example, GitHub has Git Guardian integrated now. So there's like a lot of these tools that, you know, capture any leaked potential secrets or passwords there. So that's cool. Yeah, so I think this is good. We talked about a lot of tools, if you will. One thing we really need to do, and it's definitely kind of something that is going to put the security posture in a different level, is penetration testing. And the reason for that is that the difference between one major difference between penetration testing and all these other tools is that these tools build a theory or a hypothesis around what could potentially be a problem. I'm specifically talking about SAST and DAST. Observability and monitoring, that's needed either way. But when we talk about detecting vulnerabilities, SAST and DAST do get a lot of good findings, but they do have a higher percentage of false positives. So the code flow could present a potential vulnerability, but in practice or in reality, it's not a vulnerability, or the opposite. The code flow could seem fine, but when tested, there's actually an obvious vulnerability that could be exploited. And through pen testing or penetration testing, the hacker or the pen tester would essentially provide proof that a vulnerability is exploitable, which means there's close to 100% of true positive vulnerabilities there. So what we can do here in this kind of session is talk a little bit about how we can get ready for a pen test. So if let's say we picked a pen testing vendor. So what we need to do is we need to deploy our application into a test environment, non-production environment, but production-like, as in ideally it's the exact same setup in terms of infrastructure, in terms of all the other setup that's around it, the way the code that's deployed, everything around it should be exactly as production, but it's not recommended to do pen testing in production because it could generate a lot of security noise there. Security noise in terms of monitoring, that is. The other thing is we should ensure we have a backup plan or backup in general of our data in that environment, because usually what happens in pen testing, these environments could go down because the pen tester could be trying to do a denial of service attack where they try to bring down the server. So, but if they succeed and they report the issue, we need to stand it back up quickly so that they can have more time to test different cases. So we need to have a backup and be able to spin that environment back up quickly. The other thing is to define a clear scope for the pen test. What this means is that the pen testers are going to go after the application. We could define them a set of URLs or areas of the application, if you will, that they will need to cover. And once we define that, we can kind of configure our monitoring systems to not pay attention to those kind of URLs in that given time frame. And the reason for that is just to reduce the noise there, but also to have them focus on what we need to test it. Let's say we can give them the scope based on an area where we've added a new feature, or for example, so they can test. And then finally, we can prepare a plan, or we need to prepare a plan to mitigate vulnerabilities. And the reason for that, and the reason why it's very important, is like I mentioned, like pen testing would present you with true positive findings, which means these findings are probably sitting there on production waiting to be exploited, which means you have to act quickly and fix them, especially if they're criticals or high in severity. So that's kind of the, a few things to keep in mind here.
All right. And if we're going to be thinking about finding ways to fix these vulnerabilities, we'll have to think about service level agreements. And in the security context, this would be the amount of time that we're spending to fix vulnerabilities. You can probably imagine if you have a pretty bad vulnerability, you want to get that fixed pretty quickly. So we'll want to review the vulnerability severity scoring system. One commonly used one is called CVSS, and there are other ones as well. And our pen testing vendor might use a combination of severity scoring systems to let us know how bad the problem is. So once we have an idea of that, which is usually something like critical, high, medium, low, and informational, then we can assign an amount of resolution time for each severity. You probably want to fix the criticals in the matter of days, maybe even hours if you have a very critical system as well. And we'll want to lay that out clearly, not just for ourselves and our development team, but also for our clients.
That's very good. That's awesome. All right, so we've covered a lot here. Let's talk about the DevOps or deployments aspect of things and how we can tie all this back into the development lifecycle. So if we talk about deployments, we'll talk about the DevOps kind of pipeline, if you will, and the development lifecycle. So the theme here, and you might have heard this term before, of shift left or shifting left. What this means is that we want to shift security to start as early in the development process as possible. So just for simplicity's sake, I just drew a quick kind of timeline of kind of the different stages of development lifecycle. And we'll just talk a little bit about each stage and what we can do to ensure our security in every step. So first thing is the development machine. So as Sharon has mentioned before, we could use pre-commit or pre-push hooks. These are very useful to not only compile and do quality kind of build and unit tests and everything, but we could put SAST, static code analysis there because the code is not running, and this could be a good place to put that in, especially that there are scanners now that are quite performant. We could also do third-party vulnerability scanning. What this means is that similar to Dependabot or Sneak or something similar, where they can tell us if there's a dependency that we're using in our code that is vulnerable to a given CVE, or not vulnerable to a given, that has a known vulnerability out there. And we can know that before even pushing the code to the Git server. So it's never going to be in the history potentially if we fix it locally before we push. The other thing is container and infrastructure as code scanning. What this is basically, let's say we're assuming, like most applications today, we're using a Docker-based deployment, whether it's Kubernetes or even Docker Compose or just Docker files. So there are tools out there that can scan Docker files or Docker configurations or Kubernetes configurations for secure settings. So this is also very simple to add, and it's very, quite fast as well. There's also infrastructure as code scanning. So infrastructure as code is like examples of this is like Terraform or AWS CloudFormation or Azure templates. Basically, these are basically code files that deploy your infrastructure to a cloud provider. So they actually create, let's say, your servers, your database server, your network configurations, and everything like that. Now you can, as you know, probably a few years now, it's been a trend that's, gaining traction. And you could add those files in your code base, so it moves with your code. And while that's a great thing from a maintainability perspective and quality perspective, it's also an opportunity for you to do security scans on that in the repository and make sure you have the best configurations for your infrastructure as well. So there's a lot that can be done here.
Awesome. Yeah, and I would really just copy paste a lot of that stuff into the CI pipeline for, especially when we have pull requests open, we can specify some security gates. And that means we can fail the builds if a certain number of tests don't pass, or if we find some vulnerabilities. So that's awesome. And in addition, we always want to be doing code review on our pull requests, but it could be good for us to include a security-focused code review as part of that as well.
Yeah, that makes a lot of sense. And also to reiterate, you'll notice like we've repeated some of the steps we've done in the dev machine on the pull request, and that's by design, because someone might miss. You have to remember, like with security, it's a proactive like act or a proactive task. So if it was missed in the dev machine or didn't work for any reason, we still have to do it in the pull request. And if it didn't work in the pull request, we still have to do it in the build or deploy pipeline. So same things would happen in addition to a few things. So let's say, like I mentioned, we're using a Docker image. So we can package the Docker image at this point and deploy it to a registry. Obviously, always recommended to use a private registry, especially if you're not shipping this Docker container as a product. And then we can use like the rest of the tools, like dynamic application security testing or DAST. We can run that at this point because we're now deploying a running application somewhere, and we can do our pen tests as well. So these are things that we can do in the build and deploy pipeline.
Nice. And once we have all of that covered, I think we're ready to deploy to our target environment, probably prod. And when we're there, we'll want to make sure that if we have any admin panels or admin actions exposed, that's only accessible via the VPN. And it'd be good before we deploy to double check that our cloud providers have good security practices. And like you said, infrastructure as code is super helpful in case anything happens in production and we need to shut something down, spin something up, or run something.
Yeah, that's a good point. Also, there's another kind of, if you want to really go above and beyond, and this is an important tip to note as well. So if we're talking about Docker images, I mentioned that we can push them to a registry, obviously a private one, ideally. So one of the things that could happen is that the stored image could be tampered with, as in, let's say I built an image and I pushed it to the registry. Someone could pull down that image, modify it, and push it back with the same tags, so it replaces the existing one. And then when we come to deploy, we pull down the vulnerable one. Basically, what can be done here is you would sign the image before you deploy it. And just to simplify the idea, essentially you're creating a hash of the contents of the image. And you're verifying that hash before deployment. So maybe that hash is stored somewhere else other than the registry. And then when you pull that down that image, it's verified against that hash to make sure the contents have remained the same since you've pushed it. This is, like I mentioned, this is above and beyond, but this is quite a helpful practice as well for Docker images. Yeah, I think we're ready to summarize. Is that right, Sharon?
Yeah, I think that's all I can handle for now. So let's just revisit what we're building here. So Noteware Secured, we have a multi-tenant database configuration so that we can keep our client's data separate and safe. And we'll ensure that we have proper data encryption for all the information we're storing, whether it's at rest or even in transit. And we'll be using cookies, but we'll be making sure to set those attributes for HTTP only, secure, and making sure that we have that expiry set as well. And then with authentication and token handling, we'll avoid at all costs just storing credentials directly in the database. And we'll want to be passing tokens with an expiry so that we can handle our logged in sessions that way. And then in terms of access control, after people have logged in, we don't necessarily want them to have access to everything. So we can employ methods or patterns like aspect-oriented code in order to do those checks before we execute business logic. So yeah, I think we have a good starting point for design here, and we can get started on development.
Awesome. All right, so I think this is a good time for us to, I know we're kind of right on time or a little bit above, but we could take, if people want to ask any questions. I know, Nadine, you've asked a question, and thank you so much for asking that. Essentially, Nadine was asking, what if we don't have security experience in-house and want someone to do the code review. So essentially, we do offer that at Software Secured. There are also companies that offer general code review services, just specific for code review. Like example, one company is called Pull Request that provides that. But yeah, you could definitely have security, and it depends on your cadence. You could have security code review, like what we do is on demand or on releases, as opposed to on every pull request. This could be done as well. So thank you for that question. I did notice also Saeed Rahmani, I think he mentioned something, or you were mentioning something about front end should access the external APIs through the back end. Yes, it would, and that would kind of be okay as well. But I think if I remember, based on the time you've posted this, we were talking about external access of the API and where we need to have an allow list for IPs. And this could be the portion of the API that is public as opposed to the one that is only for the front end. I hope that answers your question, but if not, then please let me know. I also noticed you posted a comment about even adding read DB in between. So just if you want to clarify a little bit more what your comment here means, we could kind of address. But yeah, and otherwise we're open for questions or comments. Or if it has been helpful or not helpful.
I just have something to add on to Nadine's question about security code review.
Yeah.
I know you mentioned that it looks like you don't have a security focused teammate or a security expert on your team, but that you're learning. And I think that's really great because Ahmad and I mean, I wouldn't call myself a security expert either. And Ahmad and I are primarily
obviously
developers.
not, yeah.
Yeah. So I think the main thing is just being conscious that security is really important and having those discussions. And it doesn't necessarily have to come in the form of like a formal code review with like perfect security background. I think just being a bit more mindful when you're building your code or when you're architecting your application to think about different ways that your application can be exploited. And we're a bit lucky because we do have our team of pen testers that we can bother with our security questions. But even if you can think of small ways that your application can be exploited, there's so much content out there on different ways that you can consider developing your app. And like we mentioned today, there's also a bunch of different ways that you can address the same problem, like cross-site request forgery. You can do that in a bunch of different ways. So yeah, I think just ensuring that you think about security while you're building and doing research when you can, that's a really good starting point.
Yeah, and I just noticed, Said, thank you for responding. Putting a private subnet or for the database, yes, absolutely, and also creating a read replica of the database so that you have the read operation separated from the write. That's actually a pretty good practice. Again, it provides a little bit more complexity in the coding side, but in security, it provides quite a good kind of. We're talking about multiple layers to make it way difficult to get to the information. So I appreciate your input, Said. Also, I know someone talked about the language. So the code snippets here were TypeScript, but the concepts apply to any language. Most kind of, especially object-oriented ones or ones that support, let's say decorators or aspect-oriented. So Java definitely applies there. I know you can do these with Python as well. So yeah, you have a lot of information here that you can leverage in multiple languages.
All right, I see Victor has a question about getting into cybersecurity and getting into the field. That's a great question. I think that's a really open-ended question. I guess for myself, I'm primarily a developer. And so I think getting into any industry that isn't, that is a bit more specific is just about having curiosity and being open to learning all the different concepts. It's not, that helpful of an answer, but For myself, like I wasn't in a cybersecurity role and I didn't have that much cybersecurity knowledge. And so I think just diving into it, getting really passionate about security, thinking about the problems and the solutions and the areas that you can take your skills into, whether it's specifically technical or maybe more just in the problem space or maybe on the product level, just finding an area to dive into a bit more deeply, and then taking whatever skills you already have and trying to apply those. Yeah, maybe Ahmad, you have a bit more to add there?
No, I mean, you've covered a lot. I think, Victor, I don't know what you've tried already, and that's a key question here. I don't know what you tried already to get into that space, but definitely like, you can look at the security companies depending where your location is also. That's another thing. So I hope you definitely find something, but keep an eye out, for a lot of security companies like Software Secured or anything, any other company, check their careers pages and kind of reach out. And I think it sounds like you have good credentials there. So yeah. I know, thanks Alex for posting that survey. So so if everyone, before you leave, or just to open the survey and answer the survey as well as, to give us feedback. While that's happening, I can answer Alba and Minal. So Alba, thanks for your question. For microservice architecture, what you need to do with inter-service requests is to treat other services as external. That's kind of the one kind of one of the things that you would consider, and basically whitelist those as or add them to your allow list to make them basically able to talk to each other. And this way you don't have to kind of do something specific or open too much there. I see, Nadeem, you want a workshop on microservices. Okay, noted. We can look into that. Sharon, you wanted to add something to Alba's question there?
Yeah, I guess one other thing is, even between services, even if they're your own services, it would still be a good idea to sanitize the inputs coming in, because you never know if in one service maybe you forgot to do that and now you're passing that data along to another service. It might be good to just double check that the data is sanitized and is in the correct format. Yeah,
I guess to your point, Sharon, what we've done internally, if we've actually built a library of sanitization kind of utilities, and we kind of include that as a dependency in all projects, and we use it. So that's something you could do as well. Okay, the question from me now: can we run a pen test on prod and to validate any fixes on prod? You definitely can, and we've seen it before. People can run pen tests on prod. It's just chances that something really bad could happen, as in like prod itself could go down because it's a pen test, and part of the pen test could be a denial of service attack where it just brings down the whole thing. So yeah, so it's definitely not recommended there. What we have always done, and we've done like multiple pen tests of applications we've built. What we do is we do testing against the staging environment, but the staging exactly matches production. And when we validate a fix in staging, we could validate it again in production, but then it's a safer kind of try, or a safer test, because we have a replica of production that we are testing against. And yeah, Sharon, I'll pass it to you to add any other color to this.
Sure. Yeah, I guess, yeah, the main concern is impact to your customers. So as much as it feels like reassuring that you've tested prod and that the vulnerabilities don't exist on prod, it is just the risk that your production environment might get taken down. And depending on how critical your application is, it could be really bad if your users suddenly don't have access to your platform, to your app, to your services. And so that's why we recommend spinning up an environment that is exactly like prod, but but is preferably on staging, so that just in case anything goes wrong, you shouldn't have any live users on staging. So if it goes down, it's all good. And since it's a replica, once you deploy to prod, everything should be the same. So you should be assured that if the pen test looks good on staging, that those same vulnerabilities won't be present on prod.
Okay. Yeah, I think that's everything. I'm checking in again the chat and the Q&A panel. I don't see any questions here. Yeah, we definitely appreciate the participation today. Thank you, everyone. It's been great to speak to you all. And yeah, please fill out the survey. Thank you so much, Arthur. And yeah, so basically, check us out, softwaresecure.com, and you can also fill out the survey to give us more feedback. And we look forward to having another session with you guys.
Thanks everyone for coming by.
Have a good day.